Let's solve another confidence interval problem related to the T procedure. Read the problem first. The director of a hospital's minor emergency department is interested in estimating the average waiting time of patients before seeing a medical professional. Assume the waiting time follows a normal distribution. The waiting time of each of the 20 patients are provided below, so everyone has a waiting time. So 23 means the first patient wait 20 minutes, the second patient wait 25 minutes, so on and so forth. So since we don't know sigma, there is no population standard deviation, then we use the T procedure and then we have a data. So this is a data problem. So where do we enter the data? We go to stat and then we go to edit to enter the data. So I already have the data input in L2. What if you want to clean up a data? So let's say L1, I don't want that anymore. How do you clean it up? So all you have to do is you move the cursor all the way up to L1 and then you hit clear and then you hit enter. So L1 is now gone. So now you can pause the video and then input the data and then come back to this. Alright, so after you input all the data, make sure they are perfectly right and then you don't have to follow any specific order. Just input these 20 numbers to your L1, L2 or L3. Now, where do you find the T interval? So let's go back to the home screen. We go to second mode to go back to the home screen and then we go to stat and then we go to test and then we find the T interval, which is in line 8. So T interval. We find T interval. This is a data problem and then I put my data in L2. I don't know where you put yours, so if you put that in L1 then you input L1. So I input second 2 for L2 and then the frequency, I just ignore that. If your calculator has a 1, just leave that as a 1 and then we are trying to compute a 90%, so 0.90. So after everything is ready, then you are good to calculate. So this one, let's round the number to 1 decimal place. So that will be 20.8 and then comma 20.2. The unit is in minute. So that means we are 90% confident that the patient has to wait around 20 to 28 minutes before seeing a doctor. So we are 90% confident that the true waiting time that means the true waiting time falls between 20.8 and 28.2 minutes. So again, confidence interval is a type of inference. We are trying to guess what the mu equals to. I don't know what mu equals to. I am trying to guess what mu equals to. What we did was I grabbed a sample from the population and then I built this confidence interval. And then I can say that I am 90% confident the mu is between 20.8 and 28.2. I still don't know what the mu equals to exactly. All I know is mu is between those two numbers. So for some problem on a book or on the exam, your instructor might want you to break this down into step by step. So that means you have to learn how to plug in numbers to the formula. So starting with the X bar, look at your calculator, you have the X bar, right? So that is 24.5 plus or minus, and then you have a T, alpha divided by 2 and the degree of freedom, and then you have an S, so that is 9.6 divided by the square root of 20, right? How do you find the T? So first of all, this is a 90% confidence interval. So that means your alpha, the remaining area, is 10%. And then you draw a T curve. So we draw a T curve right there. And then, most of the time, it is required that you draw this on your own paper. You have to, you have to check what your instructor wants, okay? So 90%. 10%, so this is a 5%, this is a 5%, the total is 100%, then you have to find this T. So our sample size is n equals to 20, so the degree of freedom is 20 minus 1, then the T is equals to inverse T, and then you have to do half alpha, so 10% divided by 2, the degree of freedom is 20 minus 1. Okay, so second, you have to go to second vars. So we go to second vars. inverse t, and then you do 10% divided by 2. The degree of freedom is 20 minus 1. All right, so you have t equals to 1.729. So this t will be, okay, let me just put this right here, this t. So this t will be 1.729. Okay, so sometimes you have to show this plugin as well. And then for the area, so the t corresponds to what area? Corresponds to these two areas. And you have to be able to shade that on your own paper. So depending on, you know, your class, your homeworks. And then other than that, you might also be asked to calculate the margin of error, which is this. So this is called the margin of error, and some book call this error bound. So all you have to do is you take 1.729 and then you times 9.6 divided by the square root of 20. So the error bound is equals to 3.711. So the confidence interval is you take 24.5, you add and subtract that, then you get your lower limit and the upper limit. Okay, one more thing. For the inverse t calculator command, the TI83 Plus does not have the inverse t command. So if you have a TI83 Plus, there are two solutions that you can do. You either go online, go to Google, and then find inverse t distribution calculator. They are all free. You can use that calculator. Or you program the inverse t manually to your TI83 Plus. How to do that? Watch one of the video. I explained that when I was talking about the t distribution and the inverse t distribution. All right, so that is the end of part B. And in part C, I would like to raise the confidence level to 99%, and then we want to make a comparison. Okay, let's do that. So 99%, so part C, we want to do a 99% CI. So part C, we want to 99% CI. So what is my 99% CI here? Stat test, and then we do a t interval. So we have to change the last option to 0.99. Okay, the C level to 0.99, and then you calculate. You have 18.4 and then 30.6 minutes. So what is the length? The length is you take 30.6 minus 18.4. So that is equals to 2.2, right? 30.6 minus 18.4. So the length is equals to, oh, not 2.2, 12.2. And then what about your 90%? Your 90%. So your 90%, you have to take 28.2 minus 20.8. So which interval is longer? Minus 20.8, that is equals to 7.4. So that tells me the 99% is longer and the 90% is shorter. Okay, so that is the answer, but why? The reason is you have to compare the t. So for the 90%, the t is equals to 1.729. What about the 99%? What is the t equal to? So the t is equals to, for the 99%, so here is the graph that you can show your instructor. So you have a t curve. 99% almost cover all the area, right? So this is 99%, and then this is half of the 1%, and then this is half of the 1%, and then this is your t, this is your t. So the t is equals to inverse t, and then you have the 1% divided by 2, and then 25 minus 1. Let's check out what that equals to. So you have second mode, second vars inverse t, and then 1% divided by 2, comma, 24. So that is equal to 2.796. So let's recall the formula. We have x bar plus or minus t times s divided by square root of n, right? So when the C level is high, so the first conclusion is when the C level is high, then you get a large t, right? You get a large t. The large t gives you a large margin of error. As a result, you have a long interval. And then number 2, the second conclusion, number 2, if the C level is low, so low confidence level, then that gives you a smaller t. And also that gives you a small margin of error, and then that gives you a short interval. Because if you only consider 90%, so 90% will be right here, right? So that will be this green T and this green T. So since we have 0 right in the middle, the green T is closer to 0. That's why the green T must be less than the purple T. Okay, so that's why when you lower the confidence level, then you get a very short interval. This is true in any procedure. The Z procedure, the T procedure, or the proportion is true every single time. Okay, let's move on to D. So in part D, I gave you some stats to work on. So in part D, this is what I gave you. I said that the sample mean is 24.5, and then the sample standard deviation is 9.6, and then and the confidence level is 90%. And then I want you to raise the sample size to 200. Okay, so raise the sample size to 200, and then before we do that, we can take a quick look at the formula. So T times S divided by square root of N. So previously, the sample size was 25, right? So now, tell me this, 9.6 divided by, make this easy, 25 versus 9.6 divided by this. Which fraction is smaller? This is not a tough problem to answer. Which one is smaller? The answer is the fraction on the right is smaller because the denominator is bigger. So that means when you raise the sample size, so if you have a large sample size, then you get a small fraction. As a result, you get a small margin of error. As a result, you get a short interval. Another conclusion is I should use another color. So if you use a small n, then you have a big fraction, or you call this standard error, then you have a larger margin of error. As a result, you get a longest confidence interval. We can do a quick look. So go back to the color that we are using, so we can calculate this confidence interval really quick. So we go to stat test, and then we do a T interval. So this one we are taking the stats option. X bar is 24.5. Okay, for some reason they asked me to access this twice in order to make that work. 24.5 and then 9.6, and then the N is 200, and then the C level, the confidence level is 90%. Okay, so we calculate. So we have 23.4 and then 25.6. So we take 25.6 minus 23.4. The answer is equals to 2.2, right? So the answer is equals to 2.2. And then what about the first one? On the first one, the 90%, we have 7.4. So the 90%, n equals to 25, we have 7.4. So this one is so much shorter because we make the sample size large. We make this sample size large. So as a result, the entire fraction, the entire standard error is small. So we get a small margin of error, then we get a short interval. So that is the result in part D, and this is true in any procedure, the T, the Z, or the proportion. If you raise the sample size, then you get a shorter interval. All right, so that is the end of this video. If you think my instruction is helpful, let me know in the comment section below. As always, like the video, subscribe to my channel, share the video for me. Appreciate your help. As always, I see you all in the next lesson. Signing off for now.